This video will cover the review and reflect for the topic of quadratic inequalities. For the review, we are asked to remember how to determine the solution set for the absolute value inequality of 2 times the absolute value of x plus 3, which is greater than 14. To solve the absolute value inequality, first we need to solve the absolute value equation of 2 times the absolute value of x plus 3 is equal to 14. First we need to isolate the absolute value. In other words, we need to divide both sides by 2 to get on the left side the absolute value of x plus 3 is equal to 7. Now we can separate this problem into two parts. The stuff inside equals to 7 and the negative stuff inside is equal to 7. Solving the first equation, we have x plus 3 is equal to 7. We subtract 3 from both sides and we get x is equal to 4. Solving the second equation, we have the negative in the parentheses of x plus 3 is equal to 7. We can distribute the negative to get rid of the parentheses, and we get negative x minus 3 is equal to 7. Solving for x, we're going to add 3 to both sides and get negative x is equal to 10. Dividing by negative 1, we find that x is equal to negative 10. So the solution to the absolute value equation is the solution set of negative 4 and negative 10. Now let's see what is happening graphically. Let's solve this absolute value equation graphically by setting it equal to 0 first. In other words, let's subtract 14 from both sides of the equal sign to get 2 times the absolute value of x plus 3 minus 14 is equal to 0. We can roughly sketch the graph of the transform absolute value function of 2 times the absolute value of x plus 3 minus 14 here. The plus 3 tells me to go 3 to the left unit. The plus 3 tells me to go to the left 3 units, and the negative 14 tells me to go down 14 units to find the vertex on my graph. The 2, found in front of the absolute value bars, is my multiplier, and it tells me to go over 1 and up 2 from the vertex. Another point will be to go over 2 and up 4 from the vertex. Because of the evenness of the absolute value graph, we can go over to the left 1 and up 2 from the vertex, as well as go over left 2 and up 4 from the vertex to complete our rough sketch. If we let y1 be the absolute value function of 2 times the absolute value of x plus 3 minus 14, and y2 equal to 0, we are asking for what x values are these two graphs intersecting each other. Recall that y is equal to 0 is the x-axis, so we are also looking for the x-intercepts of the absolute value graph. We should find them at x is equal to negative 10 and at x is equal to 4. These are the solutions we found when we solved this equation algebraically. Let's graph our solutions on the x-axis, or on the number line representing the x-axis. We will have an x value at negative 10 and another at 4. Our graph will be of the absolute value graph going through the number line at the x value of negative 10 and 4, with the vertex somewhere in between and below the number line. To answer the inequality question, we are looking for values of x in which the graph is greater than 0. From our original inequality, we can subtract 14 from both sides and we get 2 times the absolute value of x plus 3 minus 14 is greater than 0. So we want to know when the graph is above the number line. From our rough sketch, we can see that our graph is above the number line for x values less than negative 10 and greater than 4, shown here. Since the inequality does not contain the values of -10 and 4, we use parentheses in our intervals to show that they are not included in the solution. Even without completing the lecture about quadratic inequalities, you may be able to answer the reflect on this page, as it is very similar to the idea of the absolute value inequalities found in the previous unit. This concludes this video.